In this video, we will add longeron cross sections and then begin sweeping those to create the actual longerons. We'll sweep them along the guides that we created in the previous video. These here, which were created by making an intersection with the radial extrusions. The first thing we need to do, or what I'm doing here, is I entered a sketch on the plane of that first frame, which is for the plane that we had the radial cross section or radial lines on, and I'm intersecting 3D elements with all those lines coming in to create points. I would hold off on, well, you might not need to do that, but you're going to need at least one point at the bottom for what I'm going to show here. Now I've created an arbitrary cross section using a J. I think for the L23, maybe the best bet would go for a hat shaped cross section. No matter what you choose, you can always change it later using the method I'm showing. You can change it very painlessly. So I'm just going to go ahead and refine this cross section to something more reasonable. In dimension. So you should be able to go about doing all this any way you get. I got this in the end. I'm going to drag that into about position. Like I said, I'm going to work off the bottom point here. So I'm going to constrain an offset to that because our stringer here is not curved to match the shape of the skin. And because I absolutely do not want to make a separate stringer for each point along the circumference, because each point has a different curvature since it's an elliptical cross section. I'm just going to offset this and deal with the gap, because it'll make your life only about 100 times easier. Now, to get this cross section at all the other points where we need longerons, I've entered a new sketch because we're going to create the points here as something that shows up when we get out of the sketch, which means not a construction object, which means they need to be in a different sketch than our original cross section. So keep that in mind, because I know I did them in the previous sketch, but I made them construction objects, so I got rid of them. Now we're creating an axis system on each of these coordinates, and that'll allow us to do an axis to axis transformation to get the longeron in the right orientation at all of the other points along the circumference. So I'm creating some reference lines for the axes to be on. You don't have to create these lines necessarily. You just need a line that's parallel to the x-axis and one that's either parallel to the y or parallel to the z. So by going tangent to curve, we can create one that's parallel to the y through that point. At the other points, they won't be parallel to the y or z. So now I have that axis system oriented. It doesn't look like it changed at all because it didn't in orientation, but the constraints or how the axis was created is different. Now I'll create one at this point. So set the x-axis so create a line. And there are 100 different ways you can create a line parallel to the x-axis. I just had it normal to this plane. And then tangent to curve will be our y direction. If you did normal to curve, that would be the z direction. And then just make sure that there are different, whatever right-hand rule you follow, make sure all the z always points in. Because when you created that y, you didn't tell which direction was positive. And that's what I mean by right-hand rule. So now we have all these axes. We can go to the axes to axes transformation tool, which is that looking thing, profeet. Then you press your elements is your original sketch, and then your reference is the original axes, and then target is your final axes. And you can see it reoriented it according to the axes on this new point, and it looks exactly like what we want. Remember to keep your tree organized, and we'll continue these translations for the other axis systems. So here's where only doing a half model really pays off, because we only have to do half of these axes and half of the transformations, and then we can reflect them all later. And just to show you how it works, we update that one sketch and everything else gets updated. And now we will sweep these volumes, or sweep these sketches, a volume along these guide curves. And that gave us some error. Ignore what I'm doing right now. It's not going to help anything. Well, okay, never mind. It did help. Because the point that we were sweeping it along is not coincident with the sketch. There was a gap, if you remember from that first sketch. And so when you try and sweep it, you need to allow for that deviation in order to sweep along. But you saw that it intersected the fuselage in ways that we don't want. It needs to be along the fuselage. And that happens because the curvature of the fuselage is changing. So you get these compound curves. And the gap that we have is not enough to allow for fluctuations in that curvature. So what I'm going to do is increase the curvature or increase the gap that we have to work with. I'm also going to create a point or add this small addition, this little triangle section to the bottom of the cross section here, which wouldn't really be there, but this will makes the solution a little more robust because you can add this little pokey thing that we can constrain to the guideline, and that way we don't have to deal with that deviation thing that I talked about, that option that I selected when I showed the example sweeping of the curve. We can actually have it touching the curve. So I was having a little trouble picking the point that I wanted there. So I had to go through the tree and pick it. So here's what I meant by pointy thing. This little triangle sticking out the bottom. Something to remember when you're modifying a sketch is that, never mind, I take that back. So here I'm just centering the pointy thing on the bottom. And now making it join better by erasing that gap in the middle. I didn't increase the gap yet on the bottom, but just to show you don't need the deviation from guide tool. We'll do a sweep here. Okay, and now this one is running along the bottom, so there's no change in curvature as you go. Well, it gets wider, but it's not twisting at all along the line. So this is not the best example to show that the curvature is affecting things, that we need to increase the gap, but you can see what it looks like if the curvature would remain. Well, the curvature is changing, larger radius curvature, but it's twisting. So you can see when you add the twist, it starts to poke out. We will continue this in the next video.